In this topic, we will be discussing about the global patterns of climate. So, the climate of an area consists of the whole range of weather conditions experienced within that area, including the temperature, rainfall, evaporation, sunlight, and wind through all the seasons of the year. So, a particular climate will be responsible for the hosting a particular type of organism in that particular area, and that's how the climate affects the communities as well as the ecosystem. So, what are the factors which determine the climate? So, the factors which determine the climate are particularly latitude, altitude, and location in relation to the oceans and land masses. So, latitude means that how much far away we are from the equator, and altitude is that how above we are from the ocean level, and location in relation to the ocean and land masses, what is the geographical area. The climate is very important factor in determining the species of the plants and animals, and even the life forms or functional types that can live in an area. So climate is very much important in determining that what sort of plants, animals, or the life forms or the functional groups will be living in a particular area. So first we will be discussing about the latitude. So the climate varies with the latitude. As you go above the equator, away from the equator towards the pole, the climate will change. The spherical form of the earth results in uneven distribution of solar energy with respect to the latitude. In higher latitude, the energy is spread over a wider area. Thus, polar climates are generally cold, but as you go towards the equator, as the angle of incidence of the sun rays approaches to 90 degree, which is at the equator, the area over which the energy is spread becomes smaller, so that there is increased heating effect. So you will have more harsh summers on the equator. So here you can see the causes of global patterns of climate, and you can see that due to spherical shape of the earth, the polar region receive less solar energy as per unit area than the equatorial region. You can see that the earth is receiving the sunlight on the equator in much more uniform way, but as you go towards the pole, the scattering of the sunshine will result into the less heat energy as per unit area. So the latitude, the precise latitude that receives sunlight at 90 degree at noon varies during the year. It is the equator during the March and September, at the tropics of Cancer during the June, and at the tropics of Capricorn during the December. So, and the effect of seasonal fluctuation is much more profound in some regions than in other, with the greatest contrast experienced at the high latitude. So as you go towards the higher latitude towards the pole, you will have much more longer summers and harsher winters. And then there is the movement of air masses. The variation in climate also results from the patterns of movement of air masses. So air on the surface of the globe, its movement is also influencing the climatic patterns. Air heated most strongly over the equator and therefore rises, causing a low pressure area, and moves towards the pole, which is high pressure area. So we would see the patterns. Air moves towards the pole and gradually cools and increases in density until it descends, where it forms a subtropical regions of high pressure known as the horse latitudes. Air then either moves towards the equator or else moves towards the polewards. So here you can see that the causes of global patterns of climate. The B, major patterns of circulating air masses in the Northern Hemisphere. H is for the high pressure and L for the low pressure. So what happens at the low pressure, the air moves upward, moves towards the north, and it is cooled down by the air coming from the North Pole. It goes back, either goes towards the poles or it either goes towards the equator. The diagram that we have seen just yet, it is simplified and idealized picture. but it is complicated by the Coriolis effect. And what is Coriolis effect? It is named in honor of the French mathematician Gaspard Coriolis. So he was the scientist who analyzed it. It is a consequence of the west-east rotation of the Earth. The Earth as a globe is rotating from west to the east, and that results into the day and night patterns of the Earth. And doing so, it is also influencing the wind patterns on the surface of the Earth. That how the movement of air masses takes place on the surface of Earth, that is influenced by the Coriolis effect, and we will be discussing about that in detail in the next topic.